Good morning. In this lecture, we are going to study about determining the transmission line characteristics using Smith chart. So, as a first step, let us try to plot an impedance on a Smith chart. So, given a problem of finding the normalized impedance of ZL equal to 2 minus J1 on Smith chart, the first and primary thing is that in a given Smith chart, we need to identify the R equal to 2 circle. So, you can just see what you observe here is the unit circle, and the circle which is drawn in green color is the R equal to 2 circle. And the second step is that you have to plot the reactance. Since the reactance is negative, so select the lower hemisphere and identify the J1 circle. So you can just see the J1 circle marked in red color. And the third thing is that we need to determine where this R equal to 2 circle intersects with the J1 circle, and this intersection is marked as P. So from this we need to determine the angle. So we can find out the angle by taking the so we just observe here. So the angle which makes between the segment OA and the line segment OP will give you an angle of minus 26.6 degree, and the magnitude can be determined by taking the ratio of OP, so this is OP, and OR. So OR is nothing but it is a line segment from the origin to any point on the unit circle. So from this Smith chart, we can find a magnitude of OP by OR is equivalent to 0.45 and angle of 26.6 degrees. So this is the way we have plotted the normalized impedance ZL equal to 2 minus J1 on the plot. So this is the point P. So this can be used in determining the input impedance of a transmission line. So let us now see a problem. Determine the input impedance at 0.1 lambda of a transmission line. If the normalized load impedance is ZL equal to 2 minus J. So as a first step, we need to plot the load impedance on the chart. So it is being indicated by the point A. So and then the second step is to draw a circle with the center of Smith chart O as center and the line segment OA as radius. So this is the circle which is being drawn. This circle is known as the SW or circle. And as a third step, we have to move 0.1 lambda on the SWR circle towards the generator, which means that we have to move in the clockwise direction from the load. So from the load we need to move towards the generator a 0.1 lambda distance. So this is the 0.1. So you can just observe that this is the 0.1 lambda distance, and it will intersect at a point P. So this gives the input impedance of a transmission line at 0.1 lambda distance, which is nothing but a value 0.6 minus J 0.666. This can be obtained by nothing but from the R circle and the reactance circle value will give you the load impedance, so input impedance of a transmission line. So these are the formulas by which we can determine the standing wave ratio and the load impedance value analytically. So it's nothing but S equal to 1 plus tau by 1 minus tau, and otherwise ZL is equivalent to 1 plus tau by 1 minus tau. And the input impedance can be given by Z0 into 1 plus tau L divided by 1 minus tau L, where tau L is equivalent to tau into e power minus j 2 beta L, and otherwise it is the magnitude of e power j theta x minus 2 beta x. So these are the simple steps by which we can determine the input impedance of a transmission line at a given distance. So let us now just say the reflections part question. The concentric circle corresponds to a constant resistance circle or constant reactance circle, constant VSWR circle, or none of these. And the second question, in a Smith chart, incomplete circles correspond to constant resistance circle, constant reactance circle, constant VSWR circle, none of this. You can just pause for a minute and then look for the answer. Okay. So for the first question, the answer is A, which is nothing but the concentric circles corresponds to constant resistance circles. And for the answer for the second question is B, which is nothing but in the Smith chart, the incomplete circles corresponds to constant reactance circles. So thank you for watching this video. Thanks.